Hi, my name is Okwemi Omotoyimbo, and I'm gonna be taking the learning objective 2 from lecture 14 under the topic of cardiac cells, action potential, and EC coupling. So the learning objective 2 says, give an overview of the function of the organelles T-tubule, sarcoplasmic reticulum, contractile apparatus, and proteins of the voltage-gated calcium channels, SR calcium release channels, that are responsible for excitation, contraction, coupling in cardiac muscles, that is the calcium-induced calcium release. Remember that you have encountered some of these proteins in neurons and skeletal muscle, build on your previous knowledge. So I'm going to start with some diagrams because I had to draw them so it's a little bit faster as I'm making the videos. So to start, so I already draw my T-tubule, my sarcoplasmic reticulum, and kind of my myosin, and just to make things a little bit faster. So in doing this, so one of the first step is that when the cardiac action potential gets into this protein is called the DHPR. I should have made it a little bit bigger. So when this is a voltage gated channel. So when this protein, it has a receptor that's when it's activated by this cardiac action potential, when it's activated, it allows for the release of calcium from the extracellular space. So when calcium comes in, calcium is going to come in oh, hi, I'm in here. So when calcium comes in, it's also going to activate another protein, which is at the sarcoplasmic reticulum. This protein is called the RYR, also called the ryanodine receptor, if I'm pronouncing it well. So this calcium is going to activate this protein, this RYR. Let me take that again, just draw it a little bit better. RYR. So when this calcium activates this, and we also have to keep in mind that the sarcoplasmic reticulum has a lot of calcium just dancing in there, it has a lot of calcium in there. So when this is gonna when this activates this sarcoplasmic reticulum, is gonna stimulate the release of another calcium from sarcoplasmic reticulum. So calciums are gonna be released from the sarcoplasmic reticulum into intracellular space. And once this calcium is being released, it's gonna activate another protein on top of the sarcomere. This is called troponin. So when this activates, it's gonna cause so CA2+ is gonna bind on troponin, and it's gonna also activate the contraction of the sarcomere. So this is gonna contract. That is moving the myosin and the actin together. I mean, also keep in mind that there's also some reactions that go when calcium binds to troponin, which is not in this diagram, but we can see from here, once calcium binds in troponin, it's gonna activate contraction, and the sarcomere becomes shorter. So let's talk about relaxation, because if anything contracts, it must also relax. So contraction is a little bit different than relaxation is a little bit different from contraction, because now in relaxation we're trying to stop the muscle from being shocked and wanting to go back to release back into its normal state. So troponin. So one thing we have to do is that we have to get rid of calcium, because calcium also helps to activate the contraction of a muscle. So we need to get this out, and also we need, so when calcium comes out, we use we need ATP to get calcium back into the SR, because we know calcium came in from the intracellular space, from the sarcoplasmic reticulum, and also from the extracellular space. So we need calcium to go back into the SR. So we use something called the calcium ATPase. So this is going to help take this calcium back into the SR. And not just that, we should also keep in mind that calcium also came from the extracellular space right there from the beginning of this. So we need to get that calcium back into the extracellular space. So this Sure, that's a little bit weird. So calcium is try and go outside right here. But to get calcium out into the extracellular space, we need something called we need the sodium ion. We need an exchange of ion from this extracellular space into the intracellular space. So there's going to be an exchange of calcium and sodium ion. So as calcium is going out, sodium ion is going to come in. And also, like, you keep in mind that when sodium ion comes in, it's going to continue the depolarization of the muscle, and we don't want that to happen because it's going to cause contraction. So one thing we could do to reduce depolarization back into repolarization is to use a sodium potassium pump to pump in K potassium ion into the cell. So this is going to help to offset the sodium ion which is also coming into the cell. And also, like, the pump used in this when sodium comes in is called the NCX. I also forgot to talk about that. And also, like, this is also like an example of what makes this difference. Like, this is also called from this part down to this part. This is called calcium released, calcium induced process, because most of our main calcium comes from the extracellular space to even activate this reaction to go on. So I hope, like, I've been able to explain how the T tubule works, how the sarcoplasmic reticulum works, and how, like, contraction of muscle happens with the presence of some proteins like DHBL, RYR, troponin, and how you can also go back into relaxation. Thank you so much.